Next, let's talk about an application of radicals, which is the Pythagorean theorem. If you hear a dog, it's not mine. I'm still recording it, my parent. So, when given a right triangle, the Pythagorean theorem states that for sides A, B, and C, the following statement holds true. A squared plus B squared is C squared. And we can use this to solve for C, to solve for our hypotenuse. And C, that C squared, that's always the longest side right here. That's actually called a hypotenuse. I think I spelled that right. Probably not. So let's go ahead and solve for C. We'll let 4 be A and 6 be B. So I have, oh look, it's right there. I did spell it right. No, I didn't. I had an extra E. Oops. Okay. So I've got 4 squared plus 6 squared is C squared. That means I've got 16 plus 36 is C squared. 16 plus 36, that's going to be 6 and 6 is 2. 12. 52 is C squared. I'm going to have to take the square root of that to get C all by myself. Let's see if I can simplify that any further. 52 factors into a 2 and a 26, which is a 2 and a 13. So that's going to be the square root of 2 squared times the square root of 13 is C. So I have 2 squared of 13 is the length of my hypotenuse using the Pythagorean theorem. Another application of radicals is the distance formula. So the distance between any two points on the coordinate plane of x1, y1, and x2, y2 is given by the following. So the distance is the square root of the difference in x's squared plus the difference in y's squared. And we square them just in case the distance is negative. So let's find the distance between when x is negative 6 and y is 5. And when x is 3 and y is negative 4. So I'm going to draw these points. So when x is negative 6, 1, 2, 3, 4, 5, 6. Y is 5, 1, 2, 3, 4, 5. And when x is 3 and y is negative 4. So let's go ahead and find the distance between these 2 points. So I'm going to plug in these points. I have distance is the square root of x2 minus x1. So I've got 3 minus a negative 6 squared plus my difference in y, which is a negative 4 minus 5 squared. So I get my distance is the square root of 9 squared plus negative 9 squared. That's 81 plus 81. The distance is the square root of 162, which is 2 times 81. If I was going to factor it, 81 is 9 times 9. So my distance is the square root of 9 squared times 2. So 9 square root of 2 is going to be our distance between those 2 points. The last thing I want to talk about is circles. It seems kind of a weird place to throw circles in, but let's take a look. An equation for a circle with radius r and center hk, so that's its coordinate, is given by x minus h squared plus y minus k squared is r squared, where r is our radius. So if I were to find the equation of a circle with radius square root of 7 and the center negative 1, 2, I'm going to substitute in. So I have x minus a negative 1 squared plus y minus 2 squared is the square root of 7 squared. So I have x plus 1 squared plus y minus 2 squared is 7. That would be the equation for this circle. And we're going to leave it in this form. We aren't going to go ahead and FOIL out our x plus 1 and our y minus 2 because we're going to leave this in, this is the standard form for a circle. So in order to graph circles, the first thing I want to do, is find the center and find the radius. So I had x minus h squared plus y minus k squared is r squared. So let's take a look at this first example. So my x's and my y's are all by themselves. So that means my center is going to be 0, 0. And my radius is the square root of 16, which is 4. So let's go ahead and graph this circle. Here's my center, 3, 4, 3, 4. So that would be this circle right here. Let's try again in green this time. So if I have x minus 1 squared plus y minus k squared, remember hk is my center. So in this case, my center is 1, 2. So when x is 1, y is 2. And again, my radius is going to be the square root of 16, which is 4. 1, 2, 3, 4. So you count 4 in all directions, north, south, east, west, away from your center. 1, 2, 3, 4, 4, 4, and then you connect those dots, and that's the best way, in my opinion, to draw a circle. Knowing that this center point is not kind of part of your circle, it's just there for you to know how to count your radius of 4 away from the center. Okay, so let's start by identifying my center. Remember, it has to be of the form x minus h squared plus y minus k squared is r squared. So I need to rewrite this with a negative. So I have x minus 3 squared plus y minus a negative 4 squared is 9. That means my center is when x is 3, y is negative 4, and my radius is going to be the square root of 9, which is 3. So let's graph this circle. So when x is 3, y is negative 4. That's my center, and my radius is 3. So I have that point, this one, and this one. So here's my beautiful circle. For part 2, let's switch color. I have x minus a negative 2 squared, because again, we want to write that as a negative, plus y minus a negative 2 squared is 9. That means my center, my h is negative 2, my k is negative 2, and my radius is going to be the square root of 9, which is 3. So here's my new center. I count 3, north, south, east, and west. So up, down, left, right. And this would be our new beautiful circle. Okay, well, not so beautiful, but you get the gist.